Okay, so we did simplifying radical expressions, we did graphing radical functions. We're going to be solving radical equations. And a radical equation is where the variable is inside of the radical. Um, so you have to find a way to get that variable out of the radical. And your first step is going to be isolate the radical. Get just the radical by itself on one side of the equation. So you got to get everything else that's not in the radical on the other side. So in this case, I have this minus 1 that's being subtracted from the square root. So I'm going to add 1 to both sides, and then I'm left with the square root of y minus 2 is equal to 6. And now this square root, or the radical, is all by itself on one side of the equation. I have steps over here if you haven't noticed. And so the second step is eliminate the radical by using an exponent. So since this is the square root and it's all by itself on one side of the equation, I'm going to do the inverse operation in order to get rid of it or eliminate it. So I'm going to square it. Because it's a square root, I'm squaring it. But if I square the left side of the equation, I also need to square the right side of the equation. So I'm left with y minus 2, because basically the square root and the squared cancel each other out, and is equal to 36. And then my last step is to just solve the equation from there. Let's solve for y in this case and add 2, and I get y is equal to 38. And to check your solutions, plug it back in. Square root of 38 minus 2 minus 1 is equal to 5. Plug it back into the original. Square root of 36 minus 1 is equal to 5. 6 minus 1 is equal to 5, and that checks out. So for this next example, it's pretty much the same thing. Steps are the same. There are a couple things that are different though. I have this 7 that's being multiplied, and it's a sixth root, not a square root. So I still want to solve it, and I have to isolate the radical and get that radical by itself. So just like if it was 7 times x minus 4 equals 10, I'm going to do the same steps. Here you would be trying to isolate this x, this variable. Well, in this one, it's the same thing. I just am trying to isolate that radical. So my first step is going to be to get rid of the 4. So I'm going to add 4 to both sides. So I'm left with 7 times the sixth root of 5m plus 4 is equal to 14. And what's happening to this radical now is it's being multiplied by 7. So I'm going to do the inverse operation and divide by 7. And I'm left with the sixth root of 5m plus 4 is equal to 2. And now I have to eliminate the radical using an exponent. Well, because this is the sixth root, what I'm going to do is raise each side to the sixth power. So this sixth root and sixth power cancel each other out. And what I have left is 5m plus 4 is equal to 2 to the sixth, which becomes 64. And now I'm going to go ahead and solve it. Subtract 4. 5m is equal to 60. Divide by 5. And m is equal to 12. Check your answers if you plug it back in. 12 times 5 is 60, plus 4 is 64. And the sixth root of 64 is 2. 7 times 2 is 14. 14 minus 4 is 10, and that works. So it could sometimes be written as an exponent rather than a radical. But the process is the same. Get whatever is being raised to that exponent by itself, eliminate that exponent, and then solve the equation. So my first step for this one is going to be subtract 1. And I have 3n plus 2 raised to the 1/3 is equal to -1. And how you're going to eliminate the exponent is going to be, you're going to eliminate the exponent by raising it to the reciprocal of whatever that fraction is. So when I raise it to the reciprocal, I'm going to be raising it, this one, to 3/1, which is just 3. But whatever I do to the left side, I also need to do to the right side. And what happens is I'm going to be multiplying these two exponents, and when I multiply reciprocals, it's going to always equal 1. This becomes 3/3, which is 1. So it basically cancels each other out. I'm just left with 3n plus 2. And -1 raised to the third is -1. Subtract 2. 3n is equal to -3. Divide by 3, and n is equal to -1. To check your answers, I can plug it back in. When I plug it in this original, 3 times -1 is -3. That becomes -1 raised to the 1/3, which is the cube root. The cube root of -1 is -1, plus 1 is equal to 0, and it checks out. And so I have one more example of this. Same thing, I got to get whatever's being raised to the exponent by itself. So this 3 is not being raised to the exponent, and it's being multiplied to that parentheses, so I'm going to divide by 3. And I have x plus 1 raised to the 2/3 is equal to 4. And now what I have to do is eliminate that exponent by raising it to the reciprocal. So I'm going to raise both sides to 3/2. And when I raise this side to 3/2, these multiply together and become 1. So that just becomes x plus 1. And 4 raised to 3/2, I can simplify that. This becomes the square root of 4 raised to the third. So the square root of 4 becomes 2. 2 cubed becomes 8. And now to solve it, subtract 1 and x is equal to 7. I can check my answers, plug it back in. 7 plus 1 is 8. The cube root of 8 is 2. Squared becomes 4. And 3 times 4 is 12, and that works. I showed a little bit more work here. If you didn't understand how I got this 8 raised to the 2/3, change it to radical form. So the reason we've been checking everyone is because you need to check for any extraneous solutions. And it won't always tell you, but you got to check just to be sure. If you remember, an extraneous solution is a solution that doesn't really work when you plug it back in. So you can't count that as a solution. So when I solve this one, I got to add 5 to both sides, and I get the square root of x plus 7 is equal to x plus 5. And when I go ahead and square both sides here, I need to square this whole binomial. And if you remember how to square a binomial, you need to multiply it by itself and write it out twice. And so I have x plus 5 times x plus 5. And when I FOIL that out, it becomes x squared plus 10x plus 25. And so now I'm just going ahead and solving this polynomial. And so I subtract x, I subtract 7, I get everything on one side and have it equal 0. And I'm left with x squared plus 9x plus 18. And now to solve it, I should be able to factor it. And I get x plus 3 times x plus 6. What multiplies to be 18, that adds to be 9. Because this is a 1, I can go straight to my parentheses, which means my solutions are x equals -3 and -6. So when I'm plugging them back into my original equation here, I have the square root of -3 plus 7 minus 5 is equal to -3. I got to plug the -3 in for both x values. I'm checking negative 3 here. And when I simplify it, square root of 4 minus 5 is equal to negative 3. 2 minus 5 is equal to negative 3, which works. When I plug in negative 6, I get the square root of negative 6 plus 7 minus 5 is equal to negative 6. The square root of 1 minus 5 is equal to negative 6. 1 minus 5 is equal to negative 6. Well, this one does not work. So that means that negative 6 is extraneous. So my only solution is x equals negative 3. And so for this one, I have two radicals. And it's going to take a little bit longer because I'm actually going to have to get rid of each of them. And I get one radical by itself on one side, isolate, which it's already done, and I'm going to eliminate that by squaring both sides. But when I square this side again, it's a binomial, so I need to multiply it by itself. The left side becomes x plus 15. The right side I'm going to FOIL out. I get 25 plus 5 square root of x plus 5 square root of x plus square root of x squared. And this will simplify. So I have x plus 15 is equal to 25 plus 10 times the square root of x plus x, and solve from here. I can subtract x and subtract x. I have 15 is equal to 25 plus 10 square root of x. And now I have another radical, so now I basically start over. Isolate this radical, divide by 20, or sorry, subtract 25. I get negative 10 is equal to 10 square root of x, divide by 10, divide by 10. Negative 1 is equal to the square root of x. Square both sides, I get 1 is equal to x. Well, if I plug that back in, I get square root of 16 is equal to 5 plus the square root of 1. Square root of 16 is 4, is equal to 5 plus 1. That does not work. So since this was my only solution and it is extraneous, then there is no real solution. And I could have been able to tell right at this step here when it said negative 1 is equal to the square root of x. Whenever you isolate a variable, isolate a radical, and it's equal to a negative number, if that radical is even, the square root equals a negative number, it's going to be no solution, because you're never going to get a negative number out of equal to an even radical. So for example here, which equation does not have a solution? Well, if I isolate each radical, if I subtract 3 here, I get the square root of x minus 1 is equal to 1. On this one, if I subtract 3, I get the square root of x plus 1 is equal to 1. On this one, if I subtract 7, I get the square root of x minus 2 is equal to 3. And on this one, if I add 7, I get the square root of x plus 2 is equal to negative 3. The only one that has a radical equal to another number is D. So D has no real solution, or has no solution. Because no matter what I plug in for x, I'm never going to get a negative number coming out of that radical. What kind of T cannot be taken into space? Gravity.